All right, this is the last lesson in Unit 6, right triangle trigonometry. This lesson is called angles of elevation and depression. Okay. So we have two definitions to start. The first definition is an angle of elevation. An angle of elevation. An angle of elevation is the angle above the horizontal line that an observer must look to see an object that is higher than the observer. So let's say you're in this house right here, and you're looking up at the top of the mountain, okay? This is the horizontal line coming from your eyesight. And this would be the angle of elevation. It's the angle above the horizontal line, okay? When you're looking up at something, that's the angle of elevation. And this next definition is an angle of depression. An angle of depression is the angle below the horizontal line that an observer must look to see an object that is lower than the observer. Okay? So, for example, let's say you're at the top of, I think this is like a lighthouse. It looks like a lighthouse. So let's say you're at the top over here and you're looking down at the ocean. This would be your line of sight. And this is the angle of depression right here. It's the angle below the horizontal line coming from your eyesight. Below the horizontal line. So an angle of elevation is when you're looking up. It's the angle above the horizontal line. And an angle of depression is when you're looking down. It's the angle below the horizontal line. Okay? So now let's move on to some examples. I have 6 examples in this lesson. Okay? Sometimes it can be solved for angles, and sometimes it can be solved for sides. Okay? Example 1. The peak of Goose Bay Mountain is 400 meters higher than the end of a local airstrip. The peak rises a point of 2,025 meters, which is right there, from the end of the airstrip. Okay, so 400 meters is right there. That's labeled. A plane takes off from the end of the runway in the direction of the mountain at an angle that is kept constant until the peak has been cleared. If the pilot wants to clear the mountain by 50 meters, what should the angle of elevation be for the takeoff to the nearest tenth of a degree? So we're trying to solve for the angle of elevation. Okay. So let's do, I'll put an X right there. That's what you're trying to solve for. So we have to figure out which trig function are we going to use, sine, cosine, or tangent. Now, we've done this a lot this year, so I'm not too worried about you figuring out the right one, okay? But if this is my angle, this is opposite, this is adjacent, so that'll be tangent, TOA. So I'm going to say tangent of x equals opposite over adjacent. So opposite, you're going to add these together, okay? Because he wants, this is 400 meters, and the pilot wants to clear it by 50 meters. So add those together, and you get 450 for your opposite side. So 450 is the opposite side. And the adjacent side is 2,025. So that means x is going to equal tangent inverse. Because you're solving for the angle, that means you're going to use the inverse. 450 divided by 2,025. Go ahead and type that in your calculator. It says nearest tenth of a degree. So I'm going to say x is approximately 12.5288. So I'll say approximately 12.5. Okay, so I'm going to put that in a sentence. I'll say the angle of elevation for takeoff should be at least 12.5 degrees. Could be more than that. It's got to be at least 12.5 though. The angle of elevation So the takeoff should be at least 12.5 degrees. Number 2, the tailgate of a moving van is 3.5 feet above the ground. A loading ramp, which is right there, is attached to the rear of the van at an incline of 10 degrees. Find the length of the ramp to the nearest tenth. Okay. So there's a couple ways you can go about this. How about we do? I'm going to do it like this. There's a couple ways you could do it, but for my triangle, let me draw my triangle like this. That's my right angle. You want to find the length of the ramp, so that'll be X right there. If I focus on my triangle in the bottom, if this is 10 degrees, then this angle down there is also 10 degrees. Do you remember why? Because these two angles are alternate interior angles. So that means they're congruent. So for my trig function, if I'm looking at the 10-degree angle, this is opposite, and this is the hypotenuse, so it's going to be sine. So I'm going to say sine of 10 degrees equals opposite, which is 3.5, over hypotenuse, which is x. To solve for x, I'll use some quick algebra trick. X equals 3.5 divided by sine of 10 degrees. You can just switch these two around. Just switch them. X equals 3.5 divided by sine of 10. Type that in the calculator, and it says round to nearest tenth foot. So x is approximately 20.2. I'll put that in a sentence. The ramp is approximately 20.2 feet long. Okay. Now, sometimes you don't have the pictures drawn, so you should draw them yourself. Okay. So here we go. You spot a rock climber on a cliff at a 32-degree angle of elevation. The horizontal ground distance to the cliff is 1,000 feet. Find the line of sight distance, the rock climber round to nearest foot this time. Okay. So this will be me in the ground. Let's draw this is my cliff. And that's the rock climb up there. Here's my triangle. If I don't tell you how far above the ground I am, then don't worry about that. Like my eyes, if I don't tell you how far above the ground my eyes are, then you don't have to worry about that when you solve the problem. But here'll be my triangle. "32-degree angle of elevation," so I'll put that right there. Again, if I tell you how far above the ground my eyes are, then you have to worry about that. But if I don't tell you, don't worry about it. He's 1,000 feet horizontally. Find the line of sight distance. So that's the line of sight right there. From me to the rock climber. That's what I'm looking at. So that's what I'm trying to find. I'm trying to find x. So what I'm going to do is I'm going to do cosine, because we have adjacent and hypotenuse. I'll do cosine of 32 degrees equals adjacent 1,000 over hypotenuse x. And solve that for x. X equals 1,000 divided by cosine of 32. Round to the nearest foot would be approximately 1,179. So say the line of sight distance, the rock climber is about 1,179 feet. Okay, so we've done one tangent, we've done one sine, we've done one cosine so far. Let's see what's next. Okay, here's one where you have to draw it yourself. Okay, Charlie is standing 200 feet from the base of a 308-foot tall building. What is the angle of elevation from Charlie to the top of the building, round to the nearest degree? Okay, let's draw Charlie. And let's draw a building. Let's put a door in the building. Let's put some windows. It's good enough. Okay. It says Charlie is 200 feet from the base of the building. You know what? You put Charlie a little closer, just so it looks a little more realistic. Let's put Charlie right there. That's Charlie right there. I put him closer to the building just so it looks better. That's somebody else. That's Michael. Okay, Michael, we don't care about Michael. So it says Charlie is 200 feet from the base of the building. So Charlie is 200 feet from the base of the building. And it says the building is 308 feet tall. So let's say this is 308. The question is, what is the angle of elevation from Charlie to the top of the building? So let's say that's x. I'm trying to solve for x. So we're going to do tangent. Okay? Tangent of x equals opposite over adjacent. Tangent x equals opposite 308 over adjacent 200. Which means that x equals inverse tangent 308 divided by 200. Let's type that in the calculator. And it says round to nearest degree. So you should get approximately 57 degrees. Now let's put that in a sentence. The angle of elevation from Charlie to the top of the building is about 57 degrees. Okay. All right. One more page. Okay, here we go. An airplane, example 5. An airplane is flying with a horizontal distance to a nearby tower of 54,115 feet. The angle of depression from the airplane to the tower is 15 degrees. What is the altitude of the airplane? So how high above the ground is the airplane? Okay, so there's a couple ways you could do this one. Let me start by trying to draw an airplane, which I know is not going to go well, but I think that's good enough. Who am I kidding? That's terrible, but it's okay. Oh, man. All right, here we go. Let's draw some windows on the airplane. All right. Good enough. So anyway, let's draw a nearby tower. There we go. That's my tower. That's good enough. The ground right there. Okay, so the horizontal distance to the nearby tower is 54,115 feet. That's the horizontal distance. I'll label that down here. Let me draw my triangle. That's my triangle. The question is, what is the altitude of the airplane? How far above the ground is the airplane? So I'll put that X right there. So I guess the only question is, where does the 15-degree angle go? And again, there's more than one way to draw your diagram for this problem, but my 15-degree angle does not go there. It goes here. It's the angle below the horizontal line, which is right there. 15 degrees goes right there. And since it's right there, I can also put it down there because it's those are alternate interior angles and they're congruent. So I'm going to say tangent of 15 degrees equals opposite x over adjacent 54,115. Tangent of 15 degrees equals opposite x over adjacent 54,115. Solve that for x. So when I solve that for x, I'm going to multiply. X equals 54,115 times tangent of 15 degrees. Round it to nearest foot according to the directions. So tangent 15 should get about 14,500 feet. So let's put that in a sentence. The altitude of the airplane is about 14,500 feet. The altitude of the airplane is about 14,500 feet. All right, one more problem. Okay, so this last problem is a little tricky. Olivia is in a lighthouse on a cliff. She observes two sailboats due east of the lighthouse. The angles of depression to the two boats are 33 degrees and 57 degrees. Find the distance between the two sailboats to the nearest foot. Okay, so here's what I'm going to do. Let's see. Let's get a game plan, okay? My game plan is to find DB and to find DA, and then you subtract the two. That'll give me the difference, okay? If I find DB and then I find DA and I subtract the two, that'll give me the distance between the two sailboats, okay? So I'm going to start by finding DA, okay? Let's start by finding DA. So let's focus on this triangle right here. Now, these three angles up here, this is a right angle. Okay, this is a right angle right here. if from here to here is 57, that means if I do 90 minus 57, it gives me this angle right here is 33. So here's what I'm going to do. I'm going to do tangent of 33 degrees equals opposite, which is dA, over adjacent, which is 195. This is not the only way to do the problem, but this is how I'm going to do it. There's more than one way to do it, okay? So that means I have 195 times tangent 33. So that means I have dA is approximately 126.63, 44807. I'll round at the end. And now let's get dB. So for dB, let's focus on this big triangle, CDB. If this is 33, that means that this entire angle, these first two angles put together is 57. So I'm going to do tangent 57 equals opposite, which is dB, over adjacent, which is 195. That'll give me 300.2736679. If this is too much going on, what you might want to do is you might want to draw two separate triangles, one for triangle CDA and then one for the big triangle CDB. But what I'm going to do now is to get the distance between the two boats, I'm just going to subtract these two numbers. Just do dB minus dA. Then I'll round at the very end. Okay? Give you approximately 173.639, 1872. And the question said nearest foot, so I'll say approximately 174. So let's put that in a sentence. The distance between the two sailboats is about 174 feet. And that is the end of that lesson. That lesson was called Angles of Elevation and Angles of Depression.